right. So you might recognize this guy from earlier in the show. He's a speaker as well as an organizer. And today he's going to be talking to you about TensorFlow Hub in addition to AutoML. His name's Vikram, if you didn't pick that up earlier, and let's give him our attention.
Awesome. Thank you, Chris. Let's get started. Okay, so hi everybody. My name is Vikram. I'm a co-founder and tech lead at OmniLabs Inc. I am also a Google developer expert for cloud and machine learning. And today we'll be talking a bit about how we can help in your machine learning journey. So when we talk about machine learning journey, we generally expect, the expectation is that we will have the clean data, the perfectly clean data available for us to build our machine learning models. And then we will have a great compute system where we will just upload all the data, write all the code, and train our model. And once we have all of that done, we will get an amazing robot for us, which will be our AI assistant that we can use everywhere. But the reality is sadly something else. In reality, we end up with really bad data, missing values, unknown values, null values, all sorts of things. We also have, when we spend so much time in cleaning up that data and actually start using it, we realize that most of the tools don't work together. The whole infrastructure around machine learning and machine learning engineering, the whole ecosystem is evolving slowly, but there are still tools which don't work well together with each other. So we have to perform our scripting magic and join all these different things together to build something out of it. And in the end, what we get is sometimes useful, but most of the time it just ends up as a zombie code that it just lives somewhere, doesn't get deployed. Most of the models never see the light of the day, and that's the sad reality of it. But what if we had a genie that we could use to build all these models and just take away all of this complexity that we have to face when we are building these models and deploying these models and doing all this machine learning operations work? Today we heard from Anis and Carl beforehand about how to do these things on when you are using this with TensorFlow as a TFX, or you are doing this on a fully open source manner on using Kubeflow. TensorFlow TFX is also fully open source, but different ecosystems, and you can use these with different open source tools as well. But what if there was an easier way to do this? So enter Cloud AutoML. Cloud AutoML is a tool that is provided by Google on to use and build your custom machine learning models from your own data set. So how does it work? You have your own data set that you will use on Cloud AutoML, which will store that data. It will train your data for you. It will deploy that model, and you can also use it to serve. And in the end, you can use it as a REST API, or you can just use it as a batch solution on Google Cloud. You can also export that model outside. So let's see how it actually works. So we know about our Vision AI, where okay, fantastic, awesome. So we know that Google Cloud provides APIs around Vision and other tools similar to that. But if I upload an X-ray image over there, most of the information that it can give me are things like radiography, and there's a shoulder involved, which is fairly good actually. I did not expect it to give so many details around this. Like there's a joint involved, and this is medical imaging, it's a chest X-ray, details like that. But if I wanted to actually use this image to figure out whether there's pneumonia in this image or not, you can't really do that with the Vision API that is available out as a service from Google Cloud. But what you can do is you can use Cloud AutoML to train and build your own custom machine learning model. And then once you have that custom machine learning model, you can deploy it and just use that model for your purposes. So for this example, what I have actually done is I have built this model which classifies the images between whether the X-ray has pneumonia in it or not. So what we will try to do is we will try to run this model onto a local machine. We build this model TensorFlow.js, on AutoML, exported the model using TensorFlow.js. Now we are going to try to use it. So with this, running the model locally, everything is on local, no server calls are being made. And I just uploaded an image, and we will see the result here. This loading time is there because this is for the first time that I'm loading that model into the page. You can also reduce that time. I think Jason, the talk that is after me, Jason will talk more about that. So let's see. Oh, over here we see the probability of normal, that this is a normal image, is 0.61. This is 61% probability that it's not pneumonia case. Let's try a pneumonia case over here. And now we see how quickly the computation happened, because this time the model was already loaded. And the probability of pneumonia is 94% on this image. This was the data that was not available on Vision AI, the solution that is available to you using an API. But what we did was we built our own API using our own data set. So how do you actually go about doing this? For this example, I used Kaggle had a challenge that was going on, and we used that Kaggle pneumonia dataset. But for another example that I'm doing today, we will try to do something from the beginning. What we are trying to do is, we have seen a lot of examples about images, so I just wanted to do something that is non-image based. And for that, we have this IEEE dataset, which talks about how do you figure out fraud in credit card transactions. So we have some credit card data information in here, 651 MB of data information. We have transactions in here, transaction amount in here. You can see how other people are trying to solve this problem. But what we can do is we can take a look at how we would do this with Cloud AutoML. So for the first thing that we will do is we will go to our cloud dashboard. So we go to our Google Cloud Platform project. This is here we are. Now we will go to our AI section. So great thing to note, like all of the different AI tools are here. So right now we will go into tables, but you can also build custom models for natural language, for vision, for translation. I'm not sure if video intelligence is available, but you can do all of these things for your own data sets. So let's get into tables, because that is actually one of the most available data sets that people don't really use a lot. So over here, we have our data sets that we can use and build models upon. Today, we're going to take a look at the IEEE fraud detection. I have also done this talk beforehand, and every time I end up using a new database system. Okay, so let's try with the IEEE fraud detection one. So let's go in there. I've already uploaded the dataset, but I'll just show you how exactly you can do that. So let's go to import section. Generally, I tend to tell people that always upload your data already onto Google Cloud Storage, and then just point the correct bucket location. So we are going into our AutoML bucket, and I'll choose the IEEE fraud detection, and I can just select the file from here. This will be much faster than uploading the files from your local. Even better, if you are already using BigQuery, just point it to the correct BigQuery table, and it will just import the data for you automatically. Then once you have imported your data, you can go take a look at some of the information about your models and your data that we imported. We saw this on TFX as well as Qflow, that these tools are available for everyone to use on when you are doing an end-to-end pipeline. Here you can also take a look at that information. So we have information like all these different columns. Some are numeric types, some of categorical types. How many values are missing from there? How many values are invalid? How many distinct values are there? And once you assign a target column, so for this one, we are trying to, our target column is whether this transaction is fraud or not. You can see the correlation with the target as well. So sometimes you will see that some data has very high correlation. You might actually want to take a look at the data and ensure that that data is actually not nulled and like doesn't have missing values or something like that. This is also a really huge table. We have 394 columns in here, and this is 657 MBs of data. For the tabular data, that's actually huge. Okay, so we can take a look of this data. We can start doing some basic statistical analysis on this. On Kaggle, if you take a look at how generally people approach these problems, you will see that the first thing to do is understand your data. And this is a really great place to upload your data, and just very quickly you can see basic details about your data. And you can start getting sense of whether this data is actually usable or not. Then we go into training the model. So to train the model, it's as simple as giving the model a name. So let's, what I end up doing is generally I give it a name about for 3 hours. I'm going to train this model for 3 hours. The best part about this is you can just specify a number here on how much time do you want to train this model for. So for this model, we are going to train it for 3 hours. What you can also do is you can go up to 72 hours, and if your model is trained already and it can't find out better accuracy or whatever optimization objective you had, it can automatically stop itself early, or you can disable it and it will take the whole time. But I generally end up enabling it because I don't want to spend 72 hours of budget time in there. If my model approaches best accuracy or my best objective in 2 hours, I don't want to waste like next 70 hours just cause. Okay, at this point, you just start the model training. That's as simple as that. You have your model training started. What I did was I also started a training for actual 72 hours, and I did a training for 2 hours. This was yesterday. So while these models are getting trained, let's take a look what actually ends up happening when you train a model. We see some basic details right here. That area under curve is 0.56, or accuracy is 97%. That's really good accuracy. Let's see more details around this. So full evaluation. All right. So now we can evaluate our model. So not only we got the data, we trained the model. Now we are at the evaluation phase of our model. So we see that actually it's really good. We have 97% accuracy. Log loss is low. You can also set a good score threshold over here and see how it's performing at different score thresholds. So we can see like at 0.50, our F1 score is 0.49. You can also see the data and confusion matrix over here. You can see how your model performed over time during the training process as well. You can also see the feature importance. This you can use and use for later to say, next time that I'm collecting data, I will try to ensure that these values are properly filled in and they're not missing any data values. Once you have all of this, then you can actually start using it right there. To test and use your model, you can use batch prediction. So the best way to do that would be to upload the data into BigQuery. You can also use CSVs from Google Cloud Storage, and the result can also go into BigQuery or to Google Cloud Storage. The thing that I like about it is you can do actually online prediction. So we just built a model which can figure out whether a transaction is fraud or not. I wouldn't want to run this at like midnight every day. I would rather run it every time a new transaction comes in. To do that, you can do an online prediction. Now, this here won't look great because we have 393 rows in here. So what you can go is a JSON model view. And you can see the payload of the request that we are making in here. These values are in the same manner that we defined our rows of data. You can pass in multiple values in here as well. Not as much known feature. Like there's only one value that we are passing in here, one whole input. This is the complete input that we got from the user for the transaction, and we can predict with this. We are trying to predict whether it's fraud or not, and we see the confidence score is 0.99 of whether this is not a fraud. So at this point, we have the complete model, and it's available for us to actually use. We see that we just made a call over here. How would I actually make this call on server side to actually make it like from my API? So what you can do is you can go to this page. Hopefully it opens up quickly. All right. So right here, we have a Node.js example. You can do Java or Python, whichever one you are more familiar with. And it's fairly simple. You set up your project and your model path, your project ID and region, things like that, and just make the call. It's a simple predict call, which takes a payload value in and returns you the results. And you can just take all the results and return the response back. This whole code will give you the complete API that you need for your users. So at this point, like this is a pretty good model, and we can start using it. But why would I actually want to use Cloud AutoML? So let's take a look at that. So why would you actually want to use as a Cloud AutoML? We talked about like some problems that we have as users where the data is messy, or we see that there's a lot of problems around computation, model jobs break, and things like that. why would you want to use a Cloud AutoML? We as humans, like there isn't a lot of talent that is available around machine learning. We see a lot of people, a lot of hype going on around it, but when you actually look for talent around machine learning, it's really hard to find those people and actually to hire them. Let's say you actually hired a person and you are now using their skills to actually build a machine learning model. It still takes a lot of time, not only in data pre-processing, cleaning, it's also setting up those pipelines, running these experiments, coming up with the best model architecture, uh, trying to find out various hyperparameters, trying to tune them, and running all these experiments, keeping track of all those things still takes time. And moreover, as soon as you add the human cost as well as the time cost, the cost is actually high for something that you might not even end up using. So with AutoML, what ends up happening is you can use all these things. You can start using your data right away, the model for your data. One of the good things that I might have skipped over here is, let's go back to this. On training part, oh, that was right here. So let's go back to the model section. So the training will take several hours. It also includes the time to set up the infrastructure and tear down. So even this time, you are not getting charged for that. And when we consider that time into how much effort that goes into setting up the infrastructure, tearing down the infrastructure, and all these extra costs that go around building your product, it's a lot of cost, and you actually want to reduce as much as possible. So I suggest people to use as much as possible for Cloud AutoML. Okay, but what if I actually built the model, I like the model, I actually using it, but what if I actually need even more flexibility? And I've tried multiple data variations, but I'm not getting that on Google Cloud AutoML. Highly unlikely, but if you are not, you can go to TensorFlow Hub. A TensorFlow Hub is a repository where you can browse different machine learning models for your own use cases. And these models are trained models, which you can also retrain for your usage. And you can try it on different formats as well. So let's take a look at some types of models here. So if I go into image as a class, I can get image classification models in here. I can get landmark models. These are like pre-trained models. This is a collection, but there are also pre-trained models that are available in here. So let's go take a look at, there's Big GAN here from DeepMind. You can also filter for models that you're only working for TensorFlow JS, and I don't see any in here. Okay, let's go back to TensorFlow Hub, and then we will filter for TFJS only models. So you will see these models that you can use directly using TensorFlow JS in your browser. And I think Jason will talk more about these things, these models in here. You can also get models which work for TF Lite, which will be your Android or iOS devices. And these, I think, also work on Raspberry Pis. You can also get Coral devices and run your models on that. You can get these different models from here. The best part that I actually like about this is, let's go to one of the examples. Let's go to BERT. I really like, so in here, these Colab tutorials. Not only you can use an existing model, you can also learn about how can you use that model, how is that model built, and how to fine tune that model. So here, this is Colab. It's totally free to use. We have all the code in here on importing the model. So here we import the whole model, the pre-trained BERT encoder, and then we get our data set. Right here, we are using TensorFlow's data set, but you can load your own data set in here. We tokenize the data. We do all the pre-processing that we need to do, and then put the whole thing together to build the model. And you build the model, you can run it. And to run this whole thing, you can just it's a simple Jupyter notebook. And you can run this whole thing and learn more about this as well, and totally for free. And of course, there's Colby's in here. Nice. Okay, so that's TF Hub for you. But what if you are actually working inside a team, and things that you can do on Colab, you can actually share those with different people in your team, and everybody can collaborate on those repositories. But as you grow and become bigger and larger teams, you end up having trouble with not only the model file that you are using to write code in, but also the assets around models. So for that, Google Cloud provides Cloud AI Hub, which is a central place where you can come in and you can have different types of assets in here. So we talked about Kubeflow pipeline today. Let's go to the demo of this. AI Hub. Awesome. So here we have AI Hub, which has different types of assets that you can share between your team. Now, this is my personal one. I don't have any assets shared here, but you can share those assets. You can start those assets to see, have a quick way to go to those assets. Nothing in here. The page does a full reload. That's not great. Let's wait. Okay, I just want to show more about these. So you have different categories of assets that you can share. There's, of course, the data that you can share between your team. There's, of course, some data that is available from Google Cloud. I think most of this data is available also on dataset search, but you can also take a look at here, like one of the recent cases happening around COVID, and the data set is available over here as well. You can search for those datasets and look at different types of data sets. Of course, the Q4 pipelines that Carl mentioned today, you can have one of the existing Q4 pipelines. Like if you wanted to run, let's say, right here, a time series model, which works really great on if you're doing any kinds of advertisement or advertisement type of work. And you can do a time series analysis using LSTM and TensorFlow and Cloud ML engine. This is a complete end-to-end solution over here. You can do a OCR character recognition over here. Similarly, like there are more available Q4 pipelines. These are end-to-end systems that are already built that you can directly use into your projects. Of course, ML containers, notebooks, services, like all of these things are available here. Trained models as well. I don't see any trained models over here because I think all of those are available on TFHub now. But if my team built a trained model over here, you can put that here as well. So data and your model assets will come in here from your team as well. All right. The best part about this that I really love is technical guides. Again, same as TFHub. It's great to use something that is available, but it's even better if you can learn from it. There are, like, I really love this article where you can just use serverless machine learning, how to build serverless machine learning model on Google Cloud. And they talk about using vision APIs and Cloud Video Intelligence API. And it's a complete blog post here. And like with all the details around how do you want to use it. Similarly, you can filter by different types. And this is a really great hub as a central place that you can come in for all of your machine learning needs around when you're working with a team. So how do I actually go about, what would you do if you were doing a new project on machine learning? The best use case that I generally tell people, the best way to get started is start looking at the Vision AI or the already available APIs that are available from Google Cloud. You might find your answer right there. Like I was not expecting here for Vision API to actually return that this is an X-ray image or that it contains chest in here and there's a neck in here. And you'd be surprised at what this can do. Like sometimes people tell me they want to get a character from the image, and like right here we see there aren't a lot of characters in here, but there's R in here, and you can get that from here as well. Different properties, different safe search, whether this is a medical image or not, whether this is a violence in this image or not. And you can do most of these generic use cases from here on the API. If those don't work, try going to Cloud AutoML. As we talked about that, like I actually wanted to figure out whether there's a pneumonia in this image or not, how good are this person's lungs functioning. And you can go to Cloud AutoML and build your own model over there. And even then, at this point, if you're not satisfied and you still need more hands-on work, like both of these systems are totally out of your control. You can't really do a lot of those things around hyperparameter tuning and anything around that other than your data. You don't really have a lot of control over anything. On API side, you don't really have any control. On Cloud AutoML, you have most of the control over data and how much time you want to spend, but you don't really have any other control. If you really want a lot of control around how you build your models, how you deploy them, you're trying to cut down your costs and details like that, you can always go to TensorFlow Hub and AI Hub and build from there. The way I generally approach, most of my problems are generally not solvable by Vision API. So I actually start with Cloud AutoML. It's a really great place to get a quick feel about not only your data, but also what kind of models you can build, what kind of models architectures even would work And if nothing else, it would actually give you at least a baseline about what kind of models and what kind of predictions you can expect from your data. It's a very easy way to filter out projects that you don't want to work upon. Let's say a client gives you a 10 MB of file and tries to ask you to like build a machine learning model on it, and like the data is not really useful. You can't really do anything on that. So with Cloud AutoML, you can very easily run a quick search and like run a quick project on that and get a peace of mind that you didn't spend like days trying to build a pipeline and things like that when there was no actual value in doing any of that. So once things pass through my baseline criteria that this data is actually useful and we can build something useful out of it, then I actually start looking into TensorFlow Hub, Kaggle, AI Hub, or anything that is available, any literature that is available around building these different models. Any already available asset, that'd be great. Already available model, fantastic. But generally, it's not available. So either we end up retraining those state-of-the-art models that are available on TensorFlow Hub, or you end up finding a really innovative way on Kaggle by some of the winners from previous competitions, or you end up going to AI Hub and realize that some of your teammates might actually have built something like this already, and you can just fork from that and start working on top of that. And finally, once the model is ready, I really like to use my models available as quickly as possible. So they generally end up taking the point of becoming a REST API, but I really love it when I can export them out as a TensorFlow.js models and use them directly into my browser. That's my ideal workflow, and I really enjoy those kind of things. So that's actually it. If you have any questions or compliments, I'm here. Thank you, everybody.
Awesome. Thanks, Vikram. That was a lot of information in a short period of time. I think you did a great job. AutoML is really, really awesome. And, Kaggle recently used AutoML to build a spam filter instead of, there's an article about it that came out recently. I guess you mentioned cost as one factor in why you might go with AutoML and begin using that. And you kind of went over a lot of different points. Are there some main reasons besides cost why you kind of go for AutoML versus kind of building a model from the ground up?
Not really. As I talked about, like the talent around machine learning is fairly scarce, and like even though you might find a great machine learning engineer, they might be domain specific. There are engineers who only work on image data, the engineers who only work on text data. And today, you as a company might be working on text-heavy computation, but if you are a startup like us, like that might change in 6 months from now, and you might need to again find and hire a new person, bring them on board through all these processes, and on a different type of problem. And as maybe this is coming more from my startup background experiences, things change rapidly in a startup enterprise, and what you want to do is you want to have a quick way to try these things out. So not only time and cost itself, both of those are very valid concerns, but hiring itself, no matter how good of a person you have on your one team, they can't be expert in everything. And with Cloud AutoML, you get the flexibility of using tools that are already available out there.
Definitely, yeah. I think that transfer learning, framework is something that's saving a lot of time, and sometimes I find that perhaps ego becomes something that plays a part in that, being that people want to build it themselves, they don't want to use something else. But
yeah,
when you're talking about like an enterprise situation, and you need to get something done for a client, I'm in the same boat as you, where I work at a startup, and we just need to get things done, and so I think it's really awesome that this is available, and appreciate you sharing your insights about it. It's super cool.
Awesome, of course.
Yeah, awesome. I think we're ready for our next talk. Thanks, Vikram.
Awesome, thank you.